In section 2.7, we're going to do some applications of similar triangles. The triangle that you get right here, there are angles of measure 45.7 and 45.7 down on this left-hand side. So what that means is this angle is congruent to this angle. So that means we have parallel lines here. So notice how we're inside of a triangle and we have a segment inside of the triangle that's parallel to one of the sides. So that creates for us two similar triangles. So DE and AC are parallel. We can write DE parallel to AC like that. That's the notation. If we compute ratios here, DE is 7.64. AC is 9.6, and when I put that in the calculator, it comes out to 0.8. BD is 8.74. BA, I'll have to add 8.74 and 2.25. And when that goes in the calculator, I still get 0.8. And then we're going to check the right sides. So BE is on the right side, 6.44. And BC, I have to add 6.44 to 1.66. But when I put it in the calculator, I still get 0.8. So you see, the ratios of the sides are all equal. So the sides are proportional. Corresponding sides are proportional. So this indicates that the triangles are similar. Remember, you can write the similarity statement. Triangle BDE is similar to triangle BAC. Okay, this is what I want to do. Since we know that the triangles are similar, I'm going to talk about those ratios of the sides. So first of all, we said the left side BD of the smaller triangle here, making a ratio with the left side BA of the large triangle, is in the same ratio as the right-hand side. So I'm going to write BE for the smaller triangle over BC for the larger triangle. I want to do some algebra with this proportion. I'm going to leave BD alone on the top, but I'm going to change BA. Notice BA is the left side of the big triangle, and it's made up of two segments. It's made up of BD and DA. So BD plus DA is the same as BA, the segment. Then I'm going to do the same type of thing on the other fraction. So I'll leave the top alone, but the bottom BC can be rewritten as BE plus EC. So just look at that on the right-hand side. You see that BC is BE and EC put together. Okay, now I'm going to do an algebra move. I'm going to cross multiply. So going on this diagonal from the top left to the bottom right, I would multiply BD times BE plus EC. And then multiply on the other diagonal, I would get BE times BD plus DA. Then I'm going to do distributive property. So I get BD times BE plus BD times EC. Now I'll do distributive property on the right-hand side. BE times BD plus BE times DA. Notice how I have a term on the left and a term on the right that are the same. So I'm going to subtract BD times BE from both sides. That would leave me with BD times EC equals BE times DA. And now I'm going to do the reverse of cross multiplying. I'm going to undo cross multiplying. I'm going to take BD and put it on the top. Notice how BD is being multiplied times EC. So that means I need to put EC down here on the bottom, like reverse cross multiplying. Underneath BD, I'm going to put BE. And remember, BE is times DA in the math problem, so I'm going to put DA up here. Okay, look at what I came up with now. BD over BE. So that's the left side of the little triangle over the right side of the little triangle. And then DA and EC. That's this little piece down here, DA, and the little piece on the right over here. So it's like this line going through the triangle has cut the sides into proportional segments. So this is what we call the side splitter theorem. The side splitter theorem it's because the line is parallel. The line parallel to the third side has split the right side and the left side proportionally. So if you know the side splitter theorem, that can make your calculations easier. Okay, we're going to move to the next page. I'm given a triangle and I have parallel line inside the triangle to the bottom side. So we can use side splitter here if it's possible. But remember, we also have similar triangles when this happens. Okay, so CD is 3, AB is 5, CE is 6, and DB is 4. So it helps if you start labeling everything right away. The first task we have is to find AC. So to find AC, I'm noticing that AC is this little piece right here on the left. I'd like to use side splitter. I want AC, and I have a 4 on the right bottom piece, but I don't have something here with ED. So I'm not going to be able to use side splitter. What I can use are similar triangles. So I'm noticing that triangle ECD is going to be similar to triangle EAB, and that's because there are congruent angles. Corresponding angles are congruent in this diagram due to the parallel lines. I'm going to use the left side of ECD, so I'm going to use 6. 6 on the left corresponds to the left side of EA. I don't know AC, so I'm going to assign it a variable x. So all of EA is x plus 6. So I did left side of the small triangle over left side of the big triangle. Now I'm going to do bottom of the little triangle over bottom of the big triangle. So the 3 is the bottom of the big triangle. The 3 is the bottom of the little triangle, and 5 is the bottom of the big triangle. So I set up a proportion, and now I'm going to cross multiply. So I'm going to cross multiply this way first. So I have to do 3 times x plus 6 equals 5 times 6, which is 30. So 3x plus 18 equals 30. 3x is 12. So x is 4. That is side AC. So my answer to number 1 is 4. Here is the information. So we have x is 4 now, and we need to find ED. So now we can use side splitter theorem. Side splitter theorem says I can take this top piece of 6 and put it over ED. Let's call ED y because we already used the letter x. So we could put 6 over y, and then we take the bottom pieces. So this side 4 over this side 4. Oh, this is going to be easy. It didn't change. So if we cross multiply, we'll get 4y equals 24. So y is 6. You might have been able to figure that out without cross multiplying. For problems 3 and 4, we need the same diagram, but we already drew on it. So I'm going to quickly draw a new diagram. And in 3 and 4, we're told that EC is 4, EA is 6. So if EC is 4 and EA is 6, that means CA is 2, because if the whole left side is 6 and the top is 4, then the bottom has to be 2. And then AB is 4, and then ED is 3. Now we need CD. So I'm going to put a little X by CD, and it's the bottom of the triangle. So I'm not going to be able to use side splitter on this one because it's not the sides, it's the bottom. So I'm going to use the left side of the little triangle over the left side of the big triangle. So that would be 6 equals the bottom of the little triangle, X, over the bottom of the big triangle, 4. Cross multiply, I get 6x equals 16, and divide by 6, I get 8/3. So CD is 8/3. For DB, I can use side splitter. That's one of the pieces of a side. Let's call that y for now. We're going to set up a fraction with the pieces. So the 4 on the left goes over the 3 on the right. So 4 to 3. And then I'm going to do 2 to y equals 2 over y. Cross multiply is 4y equals 6. So y equals 3 halves. For number 5, perfect setup for side splitter theorem. So I'm going to take AH, which is x, and make a fraction with the right side, x plus 6. Set that equal to another fraction. The top will be 12, because that's from the left side, and then 20 is on the bottom, because that's from the right side. So let's cross multiply. I think I'll go 20 times x first. That equals 12 times x plus 6. So 20x equals 12x plus 72. X equals 9. We need to find AE though. AE is x plus 6 plus 20. Okay, we know x is 9, so what is 9 plus 6 plus 20? Good job if you said 35. Okay, we need the diagram again, but I already drew on it, so I'll get a new diagram. This does not look like a side splitter problem because we don't have the pieces of the right side. So we're going to have to use similar triangles here. I see the left side of the little triangle is x. Over the left side of the big triangle would be x plus 6. You have to take in both of these pieces, x and the 6. Now I'll use the bottoms of the triangles. So the bottom of the little triangle is x minus 2, and the bottom of the big triangle is 3. So here we go with cross multiplying. I'm going to go this way first. X plus 6 times x minus 2, and then 3 times x. So I'm going to have to do 4 multiplyings here on the left. You might know it as FOIL. So first, outer, inner, and last. And then I could put negative 2x and positive 6x together. And then I have to subtract 3x. So I have to solve x squared plus x minus 12. The answer of negative 4 is a problem because of AH, for one. So if x were negative 4, then the length of AH would be negative. So that cannot be true. Therefore, we'll reject that x answer, and we'll only use the 3. So I need to find the length of AS. AS is x plus 6. So that is 3 plus 6. Good job. For each of the questions on this page, we want to draw a nice pair of similar triangles. So we're going to have a diagram where the tall side represents the tree, and then the short height here in this story is the woman who is 5 foot 5 inches tall. We don't know how tall the tree is, so I'm going to put an X there. And the story here is both the tree and the person are perpendicular to the ground. So I'm going to go ahead and put right angle marks there to show perpendicularity. And then this angle down here on the right, this is a famous picture, and we're going to keep repeating it on this page. You have a smaller triangle over here on this side to the right, and then you have the bigger triangle as the whole triangle. And because of angle, they're similar. You see they both have a right angle, so that's one angle. And then both triangles contain this guy on the right, down here in the corner. So he belongs to the little triangle, and this angle belongs to the big triangle. They both have two angles that are congruent to each other, so the triangles are similar. I'm going to label her shadow. Now, theoretically, the sun is up here, and it's casting a shadow down. So her shadow is to the right of her, which is over here. So from here to here is 6. So from where she's standing to the tip of the triangle is 6 feet. And then the tree is cast shadow. So I'm going to change my little mark a little bit here. This whole shadow, the whole bottom, is 18. So we're just going to set up a proportion for these similar triangles. Let's go with the height of the tree over the height of the person. 5 foot 5 inches is the same as 5 foot 5 twelfths plus 5 twelfths of a foot equals the tree's shadow over her shadow. So notice on the top of the fractions, I put the tree's information. So the height of the tree and the shadow of the tree. And on the bottom of the fractions, I put the information about the person standing there, the person's height and the length of the person's shadow. Now you're going to cross multiply. So let's go this way. 6 times x equals 18 times 5 and 5 twelfths. So when you put that in your graphing calculator, put the 5 and 5 twelfths in parentheses. I'll rewrite this as you would enter it in the calculator. So enter 18, and then you could put parentheses. It will know that you're multiplying 5 plus 5 divided by 12. So you could put it like that into your graphing calculator. And then you'll probably get a decimal, and the next step on your calculator is hit divided by 6. And you should get 16.25 feet. I think the decimal that you get for this part, the red part up there, is 97.5 on the calculator. I'm sorry I didn't write that sooner. Draw the same picture again. So get yourself a nice big right triangle. The story is a 50-foot tree casts a 35-foot shadow. This tree is near the Eiffel Tower, which stands 984 feet tall. So obviously the Eiffel Tower is the tallest thing here, so that's 984 feet tall. The tree is 50 feet tall, and it's casting a 35-foot shadow. Remember, we have right angles here, which is giving us the similar triangles. How long would the shadow of the tower be? So that's down here. We want to know the whole length of the shadow of the Eiffel Tower. So this one is just like the last one to set it up. So I will do a fraction where the height of the Eiffel Tower goes over the height of the tree, and then I'm going to do the shadow of the Eiffel Tower over the shadow of the tree. So that'll be x over 35. This should be easy on your calculator now. If you have to round in these math problems, let's round to the nearest tenths place. I have a question for you that's not on here. How far apart are the tree and the Eiffel Tower? So how far apart are the tree and the Eiffel Tower? That's this length in here. How would you find that length in there? Well, if the entire shadow of the Eiffel Tower is this 688.8 feet, then you need to subtract 35 from that. So 688.8 minus the 35 feet would give you 653.8 feet. So there might be questions in your homework where they don't want the whole shadow. Maybe they just want the distance between the two objects. So pay attention to what question you're being asked. Okay, we have George and we have a tree nearby. So George is going to be the shorter height. He is 6 feet tall. Oh, and 3 inches. So that's a quarter of a foot. So I'm going to write 6 1/4 there. And his shadow is 25 feet long. Put your right angles in there. The shadow of the tree is 62.5 feet long, but we don't know the height of the tree. So this is more of a real life question. We could find those 3 measurements and then find out the height of the tree this way. So I'll do the same setup where I put height of the tree over height of the person equals shadow of the tree over shadow of the person. And the graphing calculator is helpful here, or you could just put it into decimal form. So I'm going to cross multiply. So we can round to the nearest tenths place, 15.6 feet. Number 4. A road sign is 9 feet tall, and it stands in the shadow of a light post that is 12 feet high. So this must be the road sign in the middle, because the light post is taller. The shadow of the road sign is also 12 feet. So that's on the ground. How far apart are they? So that's where you're just going to put the X in here. They're not asking us what the shadow of the light post is, because the light post is giving off the light. So that wouldn't be an actual real life question. So that the distance of the bottom of the triangle is X plus 12. That's how we're going to set up our proportion. So height of the light post over height of the road sign, and then the bottom of the big triangle over the bottom of the little triangle. So there's your setup. I'm going to cross multiply this way first. Hopefully you noticed on this whole page, I was concerned with putting the units there. So when you're asked a word problem like this, make sure you're including the units as well.